Hello, in this video, let's discuss matrix introduction. Matrix is a rectangular arrangement of numbers, symbols, or expressions in rows and columns. For example, let's consider the following matrix. Matrix A, we have a bracket here, and we have certain elements or numbers, like this. And this is matrix A. So matrix have dimensions, okay? And the dimension or order of matrices is usually expressed as m by n. So what's m? M is the number of rows. Considering this matrix A, we have two rows. This row above and row below. So that's 2. So 2 rows. Therefore, m is equal to 2, while n is the number of columns. And this matrix has 3 columns. 1, 2, 3. So 3 columns. Which means the order or dimension of this matrix is 2 by 3. Okay? Again, it's in the form of m by n. Okay? Now, let me give you another example. What if we have this matrix over here? 7, 2, 4, and let's say 9, 5, 6. What is the order of this matrix? So first, what's the number of rows? We have 1, 2, 3. So we have 3 rows. How about columns? We have 1, 2. 2 columns. Which means the order of this matrix is 3 by 2. 3 rows by 2 columns. Now, how about this matrix? Let's say 3, 0, then 8, 7, 1, 4. What is the order of this matrix? The value of m, or the number of rows, we have 1, 2. How about the number of columns? 1, 2, 3. So 3. Which means this matrix is a 2 by 3 matrix. And let's say, how about this? What is the order of this matrix? Let's count the number of rows. We have 1, 2, and 3. How about the number of columns? 1, 2, 3. Therefore, the order is 3 by 3 matrix. Next, let us try to find the element at specific locations inside the matrix. So this is the concept. The element in the ith row and jth column is A sub I and j. Okay? So let's consider this matrix over here. And this matrix is a 3 by 3 matrix. So this is a 3 by 3 matrix. 3 rows and 3 columns. And let's say we have to find the element in the first row, second column. A sub 1 and 2. So this is the first row of the matrix, while this is the second column. So it seems like they're intersecting at this value, which is 8. Therefore, the element is 8. Next, what is the element in the second row, third column? So the second row is this one. And the third column is this one. So it's like they're intersecting at the value 4. Therefore, the element is 4. How about this one? The element in the third row and first column. So this is the third row and then first column. So that's 6. While the element in the first row and third column, so first row and then third column, is this value, which is 1. Now, let's discuss classifying matrices. So we have a couple classification of matrices based on their dimensions. For example, let's consider this matrix. So this matrix over here, what is the order? This is there's only one row and three columns. So this is a 1 by 3 matrix. And as you can see, since we only have one row or a single row, this is classified as a row matrix. Okay? How about this one? Let's say we have 4, 0, 9. This time we have three rows, but only a single column. So the dimension or the order of this matrix is 3 by 1. And since we only have a single column, this is referred to as, or this can be classified as a column matrix. Now, how about this? So what is the order of this matrix? This matrix has two rows and two columns. So that's 2 by 2. And whenever the number of rows and columns for a certain matrix is the same, it means they are called square matrix. All right, how about this one? So this matrix, what is the dimension or what's the order? We have two rows and three columns. So this is a 2 by 3 matrix. And what is the classification of this matrix? Since all of the elements in this matrix are 0, therefore this is called zero matrix. Okay? And it's also possible for matrices to have multiple classifications. For example, so how do we classify this matrix? First, what's the order? We have three rows and three columns. So that's 3 by 3. And as we know, if the number of rows and columns are the same, they are called square matrix. So this is a square matrix. And there's another one. As we can see, only the diagonal part over here are not zeros. The rest are zeros. So this type of matrix is also called diagonal matrix.